Hi everybody, it's Mr. Defy once again. Welcome back to another video. In this one, we will talk about how to solve a system of equations using the substitution method. Remember that if you get an answer involving a solution, what that means is that it's a common solution, and that will be in the form of an ordered pair, x comma y. And we'll see why later on, but let's go ahead and jump right into example one. Now in example one, to use the substitution method, remember that substitution means replacing one thing with another. So you want to look at both of your equations and decide which one would be more convenient to substitute, or plug into another one. And in this case, it's very clear, if you look closely, that y is -2. And because it's -2, what that means is that this -2 can go into that y in the other equation. Okay? When you do that, you need to rewrite it. Rewriting it makes it look like this. So 4x plus 7y equals -18 is what you started with. But now what you get is, instead of 7y, you get 4x plus 7 times -2 equals -18. Remember that 7y is really like saying 7 multiplied by the value of y. Okay, so because my y value is -2, I need to set up parentheses over here to show that that 7 is being multiplied with the -2. Okay, so getting back to this, we now go ahead and solve this. And the convenient thing is that in this equation here, I only have one type of variable to look at, which is the x. And that makes it possible for me to actually solve it and find out the value of x. Unlike over here, where I have two different variables, x and y, and solving for one or the other might be a little challenging. So let's go ahead and get back to this. We have 4x minus 14 is equal to -18. Whoops. -18. And then just use the inverse properties. So addition property here and there. That eliminates. I get 4x is equal to -4. And that means, in the end, my x is -1. Okay? Now, because my x is -1, what that means is that part of my solution is -1. Now, the y value, in this case, is already given to me. It's -2. So all I have to do is take that -2, drop it right there, and just like that, I know that my common solution is at -1, -2. Okay? If we were to look at this on a graph, it would look like that. And you can see that the red line is coming from the 4x plus 7y equals -18, and the blue line is simply your y equals -2. And if you look at that black dot right there, you can see that's a point of intersection. That is where these two lines meet. And so that -1, -2, when we look at it here, represents not only a point of intersection, but it's also a common solution. And the reason it's called a common solution is because when you take those numbers, -1, -2, and you bring them over to the two equations that you worked with, those two numbers representing your x and y coordinates, they are supposed to make both of these equations true when you substitute them in. And so here we go. Let's put it to the test. In the first equation, y equals -2, my y is -2. It's already telling me that. So honestly, there really isn't work to do for this one, but to be complete, let's go ahead and replace this y over here with the -2 that we know it is. And as you can see, those two numbers look the same to me, and that is a true statement. Hence the smiley face. Then in the second one, we do the exact same thing, keeping in mind where these numbers each go. So what we get is the following. This requires a little more work, so just be patient, take your time, do a good job. So this is 4 times -1 plus 7 times -2, and your entire goal here is to figure out whether or not everything on the left will become the number -18 on the right. So let's break this down. This becomes -4. This is -14. That's still -18. And look at that. I get a perfect match. So indeed, this is another true statement. Okay? And so we can see that -1, -2 is not only a point of intersection, as you see right there, but it's also a common solution. It works on both equations. And that's example 1. So let's go ahead and move on to example number 2, where in this example, the difference is that I'm not given the value of either neither x nor y. I don't know what they are. And that's different from example 1 because in example 1, I was told, oh, y is -2. Okay? But I need to do a little more work in example 2 to figure out my answers. One thing I want you to know is whenever you're in a situation like this, in the substitution method, what makes it work is being able to substitute one equation into another. And the only way that this can happen is if one of your variables is completely isolated on one side. And if I compare these two equations, I can see that this little y over here is indeed isolated. So I'm all alone. But that's fine. We want you to be alone. Why? Because that means that we can now take the 4x plus 3 and plug it in to the y part of the other equation. Okay? So it's like the 4x plus 3 is in disguise, posing as a y, right? And so what we get when we rewrite this, because we have to rewrite it when we substitute it in, what we get is the following. We have 2x. That's still the same. This is -4, but because I'm plugging in, substituting two terms in place of 1, I need to show parentheses because remember, that's 4y, and 4y is really 4 times whatever y is. And because my y is actually 4x plus 3, that whole thing goes in parentheses, and then I solve it. All right then, so breaking this down, be careful with your math. Here we go. So this will become, if you distribute, you get 2x minus 16x minus 12 equals 2. Combining like terms, what you get then is -14x minus 12 equals 2. Addition property on both sides will give you -14x equals 14, and then the division property on both sides will give you the result. So x is equal to -1. Okay? All right then. So if my x is -1, what that means is the common solution already has a component of -1. And just the fact that I can get an answer like this, a numerical answer, means I really do have a common solution. Now my next task is to get the y. And in order to do that, I need to look at both of my equations again. Because x being a -1 means that I could substitute that number anywhere I want. I could plug it in here if I want. I could plug it in there if I want. But I need to choose one. And my advice is go with the equation that is easiest. So that would be the second equation, because as you can see, in the second equation, the y is set up. All you have to do to get the value of y is multiply -1 times 4, and then add it to 3, and you have your answer for y. So let's go ahead and do that. So we're going to take, oops, I did this the wrong way. So we're going to take x equals -1, and we're going to substitute that, sorry for my bad writing here, we're going to substitute that into 2x, y equals 4x plus 3. Now when we do this, again, be careful with the math, we get the following. Y equals 4 times -1 plus 3, which is like saying y equals -4 plus 3, which is like saying y equals -1. And if you're thinking, well, I got the same answer as my x, that's okay. Okay, math sometimes is funny like that, but just go with it. So our common solution is -1, -1. And to prove to you that it really is a common solution and a point of intersection, let's take a look at this graph here. You can see that my two lines really do intersect at -1, -1. The blue line is y equals 4x plus 3. The red line is the other one, 2x minus 4y equals 2. And that green dot you see, that's a point of intersection. And if you look at the coordinates, -1, -1, that's the same thing I got over here, -1, -1. So it's not only a point of intersection, but it's a common solution. And we're going to test this out very quickly because we always have to check our answers here. It's a good idea. We're going to do a quick answer check. And we're going to compare both functions together to see if it works out. The first one was 2x minus 4y equals 2. And the next one was y equals 4x plus 3. So y equals 4x plus 3. Just to do a side-by-side comparison, remember we're comparing -1, -1. Plugging them in, you get the following. 2 times -1 minus 4 times -1 equals 2. That's -2 plus 4 equals 2. And just look at that. I get the same thing. That is a true statement. On the right side, -1 equals 4 times -1 plus 3. That's going to be -4 plus 3. And look at that. I get a true statement again. So if it works, if this single order pair, -1, -1, which is my x and y value, if those numbers work on both equations, that's why it's called a common solution. If they both intersect at that one point, -1, -1, that's why it's called a point of intersection. Okay? So it's two different names for the same thing, essentially. And that's the end of our second example here. I hope this video helped you out. The substitution method does have another part to it, which I will make a video for tomorrow. Please do stop by and check it out. And as always, leave a comment, and I hope to see you next time. Take care. Bye-bye.